Hey there guys, welcome to the notes videos for polynomial operations. This is your 4.1 notes. Starting off, we're going to start with just general combining like terms ideas. So this is something you should have seen from Algebra 1 and something you've seen a little bit scattered throughout our units 1, 2, and 3. So first, we're going to get very technical with how to classify polynomials, what it means, and what type of polynomials we'll have. So polynomials can be classified by their number of terms. So a term is the parts of an expression separated by an addition or subtraction sign. So for example, here we see that there's only one term, nothing being added or subtracted to it. So when there's one term, we call it a monomial, where mono means one. And then we can see that, okay, well, now we have the sum of two monomials, which we have two terms because we see there's an addition sign, so there's two items within our expression. And this is what we call a binomial. Where bi means two, like bicycle. The sum of three monomials are three individual terms. So we can see here we have some three individual terms, 1, 2, and 3. We will call that a trinomial, where tri means three, like tricycle. And finally, a monomial of more. So we mostly only specify with monomial, binomials, and trinomials. Everything else we call a polynomial. Similar to polygons, which are just shapes with more than three sides, or more than two sides, because you have triangles, which also mean three sides. So you have different types of shapes. And in this case, we have different types of expressions, or polynomials. So monomial, binomial, trinomial, and then just generally binomial. They can also be described by their degree, where degree is their exponent, really. So for a single variable expression, we look for the variables with the highest exponent. So whatever exponent they have, that will be our degree. And then that's what we just say is degree for the entire polynomial. So the largest exponent is going to be what we use to classify our degree. So for example, a polynomial degree 1, that is to say where I have an x value, was just a 1. That is what we're going to call a linear expression, which makes sense. Y equals mx plus b. When you just have an x, it's linear. Versus when we have an x squared, if you remember, this is the quadratic. Then if we have an x cubed, well, it's cubic. And then finally, the highest we really go in Algebra 2 is quartic. Where quartic means, hey, we're raised to the 4th power. So if you have your largest exponent is a 1, it's a linear. If your largest exponent is a 2, it's quadratic. 3 is cubic. 4 is quartic. Now, this is really, really important down here. Polynomials do not contain variables that have negative exponents. So if you have a negative exponent, it's not considered a polynomial. Values that are in the denominator. So anything like this does not count. If you have a fractional x value, it's not considered a polynomial. It's considered a rational. And variables that have non-integer exponents. For example, x to the 1/2. So if it's raised to a non-integer value, so not just to a 1, 2, a 3, no whole numbers, you get like fractional values, it's also not a polynomial. And anything that's underneath a radical, also not a polynomial. So we can go from here. So what we need to do next is we need to classify these based on their degree and the amount of terms. So starting off, I can see that this one has 1, 2, 3 terms. So it's going to be a trinomial because it has 3 terms. So number of terms, 3. My degree, my largest exponent, is 4. So it has a degree of 4. So we're going to call this, degree goes first, so my degree when it's 4 is quartic. So I'm going to have a quartic, and when it has 3 terms, we call it, remember, a trinomial. So quartic trinomial. Quartic because of the degree 4, trinomial because it has 3 terms. And then, let's go to example B, 6x squared plus 2x plus 7 over x minus 2. Now you may say, okay, this has 3 terms and its degree is 2, but halt. Remember earlier, we made an important distinction, which is that we cannot have polynomials that have negative exponents, fractional exponents, or have a radical symbol, or are in the denominator spot. Look, we have an exponent in the denominator spot. So this is not a polynomial. Let's use a different color. And then remember, it's not a polynomial because it broke this rule here. We cannot have variables that are in the denominator. Go to the next one. Now, although we do have a number in the denominator, my variable is not in the denominator. This one's just a fractional value. So this one's okay. So we can actually call this, and we can say, okay, well, I have degree 1, and I have 1, 2. The 1/3 goes with the x. So I have 2 terms. So degree 1 is linear. Oops. Linear. And 2 terms is binomial. So you have a linear binomial. And then we go to our next ones. We can say, okay, there's none of these rules are getting broken, so I can count them like normal. My largest exponent is 3. I do have an exponent of 2 and an exponent of 1. Remember, we classify them based on their largest exponent value or their largest degree. So in this case, my largest degree is 3. And I have 1, 2, 3, 4 terms. So I have a cubic, because that's what I have when I have a polynomial of degree 3. And then 4 terms, we will just call a regular polynomial. Now, if you look at part E, you can see that we have 3 terms, but we're breaking a rule. We cannot have variables that are under a radical symbol. So we cannot have square root of x, which we do. So this one is another one where it is not a polynomial. And then finally, we have this case, which does not break any of our rules. And we can see that my highest degree is a 2. And there's only one item in this expression. So when it has degree 2, it's a quadratic. And monomial, because it has 1. Ooh, we just got that to fit. Quadratic monomial, a little bit messy. So this is just how to classify polynomials based on their degree and their terms. So make sure you know how to do that. This is just practicing your vocabulary. Now we're getting into the actual math of how to do these problems. So, let me scroll up a bit. So for adding and subtracting and multiplying polynomials, we have general rules. For adding and subtracting, you just want to combine like terms. For multiplying, you just multiply like normal, except that x times another term will give you x cubed. But we'll go through these little by little. So we have our first expression, which didn't get copied on my document, so I'll just rewrite it. So for example 1, we have parentheses 5, and let me make this smaller. Parentheses 5 xy plus 3x squared y in parentheses minus 2xy plus 5x squared y minus 6xy squared. So first off, to start this problem, anytime you see parentheses, you have to ask yourself, am I able to distribute? In front of my first parentheses, there's nothing, so I'm not going to distribute, but in front of this parentheses, there's a minus sign or a negative sign. I have to distribute this negative. So that will be my starting point. So I'm going to keep my 5xy plus 3x squared y, because nothing got distributed here, but here my 2xy got distributed, so it's a negative 2xy, which most students are able to do, but they always miss the negative times the rest of the terms. So negative times 5x squared is going to be negative 5x squared y. And then negative times the 6xy squared is going to give you positive, because negative times negative, 6xy squared. So this, now that I got rid of parentheses, is where I can start combining like terms. So let me start combining. So I see, let me start with my biggest exponents of a 3x squared y and a negative 5x squared y. These can get combined because they both have an x squared y. So they're considered like terms. So I'll just subtract their coefficients. 3 minus 5 is negative 2, so negative 2x squared y. And then we go to the next of my expressions. We see that I have a y squared, so here's my other variable with a large exponent. Except this, let's use a different color actually. Maybe pink. This one right here is the only one with a y squared. No other expression has a y squared, which means it does not combine with anything. It'll just stay the same. So I'll keep it as xy squared. And then finally, my lowest degree value. Now for the most part, it really doesn't matter what order you write these in. Typically, you want to write it from the highest degree to the lowest degree. That is, from the highest exponent to the lowest exponent. It doesn't really matter as long as you're combining like terms correctly. So I can combine these two because this has an xy and this has an xy. So 5 minus 2 is 3. So that's going to give me 3xy. I cannot combine any further from here because this is the only value with an x squared. Now you might say these both have x squareds, but this one has an x squared, this one has a y squared. And although all expressions do have an xy, this is the only expression with an x squared y, where this one's xy squared and this one has no squares at all. For my next problem, it was parentheses 3d minus 4 times 3d plus 4 minus d minus 2. So same thing, anytime you see parentheses, you first want to start to see if you can distribute anything. Now there's a couple of things you can do. I see a parentheses touching a parentheses, which means I can multiply. I also see a negative in front of a parentheses, which means I can distribute the negative. So this will have multiple things that are going on here, which is okay. So let's start here. So when you're having a binomial that is a two-termed expression times a binomial, another two-termed expression, you are going to use FOIL. So if you don't remember what FOIL is, it's first, inner, outer, last. So we're going to multiply my first terms together. 3d times 3d, which is 9, because 3 times 3 is 9, d squared. Because d times d is d squared. Inner, so my inner numbers together. So negative 4 times 3d, which is negative 12d. Outer, 3d times 4, positive 4 this time. So positive 12d. And last, my last terms. Negative 4 times positive 4, which is negative 16. You can also do something what we call double distribute. So you could have just done 3d times 3d, 3d times 4. And then distribute your second term, negative 4 times 3d, negative 4 times positive 4. That also works. Now for my next part, I need to also distribute this negative. So this is really negative d plus 2. So be careful there. Once you've gotten rid of your parentheses, and you do that once you've distributed or once you've multiplied, you can start combining like terms. Remember, we like to start with the largest degree. So in this case, that's a degree 2 or an exponent 2 is my largest. So we'll start here. So that's going to give me 9d squared is my largest. There's no other number with a d squared, so it's not going to change. Nothing's getting added to it. Nothing's getting subtracted to it. However, I see that I have a 12d and a 12d here. These can combine because they're like terms. They both have d. So negative 12d plus 12d is 0. So they cancel out. But I also have a minus d right here. So those d's right here, 12d minus 12d, canceled out. So it's 0, but I keep my minus d. So 0 minus d is just minus d. Or 0 minus 1 is negative 1, which is what this is implying. Finally, I have the negative 16 and the 2. So negative 16 plus 2 is negative 14. And that is my answer for the second one. So we're just combining like terms as we're going along. My next expression is 8k squared minus 7k minus 1/2, 6 minus 8k plus k cubed. And same thing, I see parentheses. I need to make sure that nothing's going on with this parentheses. On the first one, for my 8k, there's just a parentheses here, nothing in front of it, so I can just bring it down because nothing's going to get multiplied to it nor distributed. So it's just going to stay 8k squared minus 7k. But here, I know I'm going to distribute not just that 1/2, but that negative 1/2. So negative 1/2 of 6, or half of 6 is 3, so negative 3. Negative 1/2 of negative 8, or half of 8 is 4, and negative is positive, so positive 4k. And then negative 1/2 times k is just negative 1/2 k cubed. And I can start combining my terms as they go along. I can start with my largest degree, or my largest exponent, which is just going to stay as negative 1/2 k cubed. There's no other variable with a third power with a cube. See if I find any other squares. Oops, thought I changed the color. And we can see that there's no other k that has a k squared, so that one's also going to stay the same, plus 8k squared. I see I have a minus 7k and a plus 4k, so there's two things I can combine here. So negative 7 plus 4 is negative 3, so I'm going to have a negative 3k. And then finally, I can see that there is no other constant value, a number without a variable, so that will also stay the same. So my answer is negative. I know it's getting kind of cut off, so let me see if I can move this a bit. Negative 1/2 k cubed plus 8k squared minus 3k minus 3. My final problem, this is kind of a typo right here, so ignore that, is, so we're going to ignore that, 2x minus 9 squared. So first off, anytime anything's getting squared, we know that means it's being multiplied by itself. So what I'm going to do is I'm going to rewrite this as 2x minus 9 times itself, another 2x minus 9. And then we're going to do the same thing we did here, FOIL. This time I'll use double distribute, but you'll see what that means. So we're going to take my first value and multiply by the first value. So 2x times 2x, which is 4x squared. And then I'm going to take my 2x and multiply it to the second value in the second parentheses. So 2x times negative 9, which is negative 18x. Next, I am going to do the same thing, but with this is why it's called double distribute, because you distribute twice. This time I'm going to distribute the negative 9, the second term in the first parentheses, times the first term in the second parentheses, which is going to give me negative 18x, and then the negative 9 times the negative 9, which is positive 81. Here, the only thing I can combine are my x terms in the middle, the negative 18 and the negative 18. So the 4x squared will stay the same. Negative 18 plus negative 18 is negative 36, keep the x, plus my 81. So that's all just combining like terms. Finally, we are going to go to example 3, which has me kind of solve a geometric problem, kind of going back to geometry. So we're told that the leg of an isosceles right triangle is represented by an expression x plus 3. Remember that isosceles means that you have two equal sides. And let me just re-highlight that was in a nice color. So two equal sides. So let's draw something to represent this. Here's my triangle. And here are my two equal sides, or my two congruent sides. Remember, these lines mean congruent. They're the same. And we know that one of my legs can be represented by x plus 3. Well, if they're congruent, I have another x plus 3. I don't know my hypotenuse because they didn't tell me my hypotenuse, but I at least know this much. Then they tell me I have to write and simplify an expression representing the area of the triangle. So remember, for areas of triangles is represented by area is 1/2 base times height. I have 1/2 my base, which is x plus 3, times my height, which is x plus 3. Which this is going to become, we can double distribute here. So I can do x times x, which is x squared, x times 3, which is 3x. Then I can do 3 times x, which is 3x, and 3 times 3, which is 9. So that's going to give me x squared. These can combine, plus 6x plus 9. Before I circle that, we have to remember that actually there's still a 1/2 in front of everything. So I have to take half of everything here. So half of x is just 1/2 x. Half of 6 is 3. And half of 9 is just 9/2. So that's my answer, 1/2 x squared plus 3x plus 9/2. Remember, that 1/2 came from my expression 1/2 base times height. So I did my base times height to get this expression, then I had to take half of everything. Now, you don't have to turn them into decimals. I'd suggest leaving them as fractions, but that's it for your notes. So if you have any questions, let us know. Otherwise, See you in tutoring or have a nice day.